here. Myself, I am Ramesh, Assistant Professor in the Department of Aerospace Engineering. I am being with my mentees from 3rd year Aerospace Engineering Department. Today we are going to discuss a case study topic on Black Saturday rocket launch failure happened in China. And this is a very tragical one. The launch happened at the satellite center at China. It is considered the most disaster one, as well as severely it is considered a very huge disaster in the space flight vehicle history. That's the thing here we are going to discuss. Our mentees are here to discuss what about the background of this rocket, as well as what happened in this disaster. That means the sequence of failure happened, then the impact of the disaster of this rocket launch vehicle, and finally it will be summarized how and what would be happened, how it can be avoided. This kind of things will be summarized. One more thing, actually, mainly it was happened on February 15, 1996. It was expected for the launch to demonstrate how the China having the capability in the international market, to prove they are very strong in the space oriented space point of view. They are very much strong in that. Currently they have done this kind of launch vehicle, but unfortunately it was a very huge disaster happened within 22 seconds itself. Crash happened on the hillside of the populated areas. So those kind of things will be summarized here. Now let's start with our mentees from one by one.
Good afternoon. Let me tell about the mission profile and the launch vehicle of the failure. So let me first discuss about the Long March 3B. So this is the Chinese launch vehicle, and it was ready to launch the Sijion satellite series in the orbital. The main aim for this launch vehicle is to launch the satellite in the geo-transfer orbit, but unfortunately it is a three-staged vehicle. At the upper stage of the vehicle there is a mixture ratio fault, and due to that both the vehicle and the satellite were lost. So this led to the tragic failure of that Long March 3B. Next, let me tell about the SNS. This is a private company owned launch vehicle by Galactic Energy. It's a private company in China, and they aim to launch the satellites, many satellites, with the maiden flight in the orbit, but unfortunately within the early ascent, in the initial stages of during the takeoff, the satellite was failed, so it can't take to the orbit. So this both tragic accidents marked as a Black Saturday.
So good afternoon everyone. My name is Kritika Bhatta from 3rd year Aerospace. So now we are going to discuss about the failure mechanism of Long March 3B rocket. So from the aerospace system point of view, there was a problem in the upper stage of the Long March 3B rocket, as the upper stage is responsible for placing the satellite accurately in the orbit. So even a small issue like the ignition time or the mixing of fuel oxidizer ratio, and also the guidance and the navigation system can cause a mission failure. So this explains the importance of the upper stage ignition system should work properly, especially for the missions like when the satellite needs higher energy to reach the orbit.
So good afternoon everyone, I am Lavaniti from Aerospace Engineering. So I am here to talk about the failure mechanism of CERES-2. So the CERES-2 failure, the characteristic of it was the maiden flight risk. So the key aerospace challenges include limited ground to flight correlation, and the structural and propulsion challenges, the coupling issues, the dynamic stability and dynamic pressure and the vibrational uncertainties. So since the solid rocket motor cannot be started or it cannot be stopped or throttled, so this led to the quality testing become more critical and extreme.
So good afternoon everyone. My name is Srimati from third year aerospace engineering. I am going to tell about system level impact and programmatic risk. From a programmatic standpoint, this dull failure caused mainly 5 reasons. The first reason is loss of classified and commercial payload, and the second one reduced confidence in private launch startup, and for a growing spatial ecosystem balancing launch cadence. um, for a growing space ecosystem balancing launch um, and the third point, disruption of launch manifest, and fourth point, for a growing space ecosystem balancing launch cadence with reliability engineering is a major challenge, and the final one, increased security on quality assurance and control.
Good afternoon everyone. I am Deepa, third year aerospace engineering. In conclusion, this last Saturday teaches the very important engineering lessons. First, the upper stage of the rocket is very important because even a small problem that can fail the whole missions. So second one is maiden flight. We can use safe and conservative design margin, and third one is the when companies are grow fast, the testing is they should never reduce the testing and verification. Finally, the failure not the end. In aerospace engineering, failure help us to learn. So the design improve the design in the future. Thank you.
It's a nice contribution from our student side. I have talked about rocket launch failure. Since they have studied rockets and missiles and this in this semester, so they are very much enthusiastic about the current trends as well as the past scenarios also. So they have taken care of everything, and they will do something in future also. In the next week also, they will do some space related topics. They will present as publish as a video. I think so. So it's a nice contribution from your side, and I think it will be helpful for you to know about what happens in this failure, and what will be the root cause, what would not be done, as well as impact of the disasters. It will be a very huge one. Okay, so taking into account all necessary activities as well as the testing before launch, and all the payloads as well as what we have seen in the main components of each and every parts in the rocket systems. To be thoroughly checked whether everything will be in a correct ratio. As well as the propulsion point of view, you are taking that is the mixture ratio. Okay, the mixture ratio of propellants. Okay, that is very, very important. Plays a very important role in this disaster. Okay, so accordingly we have to do this. So we will do in the next class of next video also the